Hey students, so my name is Zamani Samson and my cameraman is Sufyan. So let's start from introducing Euclid. So Euclid was an ancient Greek and genius Greek mathematician who lived over 2,300 years ago, and he was known as the father of geometry. But he doesn't only explain or discover or invent geometry, he also invent or explain about numbers and number theory. He was, we don't know where and when he was born, but we do know where and when he was lived. He was lived in Alexandria around 300 BCE, Alexandria, Egypt. This was during the Ptolemy, the first ruled after the great Alexandria the Great, and his famous book was the Element. The Element contained 13 books, and it talks about lines, angles, triangles, circles, and street shapes. He also explained things like ratio in number theories, and he is important still today. I know you have a question on this. The question will be why he is important, and he is important because he explained geometry like cool way, and he made a sense on it because of that. So the second part is about number theory, relationship with number and number theory. So if we have a number that's called Euclidean number or Euclid number, and we have formula. Let's start from formula. The formula is En or Euclidean number equals to 3n sharp plus 1. 3n means prime number. And Euclidean number is made by multiplying the first n or number prime number and adding 1. So Pn or prime's number sharp is the product of the first n prime number, that's called primorial. So it proved for him the infinity of prime number. And the property it have the odd property. The odd property is and 30,031 is not prime number, it's composite number, but it achieved in number of Euclid. So Euclid have other contribution. The first one is Euclidean algorithm. It helps us to find GCD or greatest common divisor. The second is fundamental theorem of arithmetic. It helps us to break down every numbers to prime numbers, and the third is perfect number always equal to proper divisor. For example, 6 and 28. 6 equals to 1 times 2 times 3, and 28 equals to 1 times 2 times 4 times 7 times 14. So still now he is important on Euclidean number because he gives us the cool way to think about prime numbers and number of theory. Let's move to the part 3. So the part 3 is about his work history. He works, he discovered or he invent or he explained about geometry, and he's the father of geometry, as I mentioned before. And the Element is his famous book. It contains 13 books or chapters. So from book 1 to up to 6, it talks about plane geometry, and from 7 to 10, it talks about number theory, including prime number and GCD. And from 11 to 13, it talks about solid geometry and platonic. It's the one of the most famous texts ever, and he also wrote about how light travels, how to handle given information in problem, and how to start how the star moves in the sky. And we know that stars move from east to west. And other contribution on his work history is the first one is GCD or common greatest common divisor he got from this invented Euclidean algorithm. And the second is prime. It proves infinity of primes. And the next is ratio. It helps us to think logically or to compare them logically. And even in odd number, it helps us to invent multiplication rules. The next is perfect number. It's defined and explain how to find them. And finally, math proof. He invented this because he wanna think. He wanna think without guesswork. He wanna think like logical thinking. Because of that, he invented math proof. So let's talk about perfect number and even and odd numbers. So perfect number equal to the sum of its proper divisor. For example, 6 and 8, and it have the formula 2 the power of b minus 1 times in the bracket 2 the power of b minus 1. This is for perfect number. And even in odd numbers, as I mentioned before, it helps us to invent multiplication rule, and the formula is e times e equals to e, or even times even equals to even, and even times odd equals to even, and odd times odd equals to odd. The last part is about the books. So he discovered, or he wrote 10 books. So the first is the element contain about geometry, number theory, and proportion, and its status is still fully preserved. Because of that, the element is a very famous book. And the second is data. Data, it talks about, or Euclidean data, it talks about geometry, and its status is still preserved. And the next is one division of figure. It talks about geometry figure, and it's partially lost. Phenomena. It talks about geometry of stars, and it's preserved. The next is optics. Optics talks about visual precipitation and light path. It's preserved. And catoptrics. It talks about reflection in mirror, and may not be Euclid robotics, and it's lost. Prisms, it talks about geometry, proportion, and construction. It's fully lost. They just found the titles. And the next is surface loci. Loci means locus or location. It's defined about the location problem in geometry, and it's fully lost. They found the title only. The next is pseudaria. Pseudaria is talks about common math fallacies. It's only they can get only the title, and it's fully lost. The last is conics. It talks about early study of conic section. It's lost. Maybe conic doesn't write by Euclid. So I'm done. Before I run into the textbook, if you have any question.